Hey everyone, and today we're going to be going over sort of L'Hopital's rule and an example of L'Hopital's rule, so just like basics. And so essentially what L'Hopital's rule does is it allows us to find the limit of some function when we have it expressed in indeterminate form. So let me go over what that means first. So we're not going to use this function yet. Instead, I'm just going to go over the basic indeterminate forms so that you know when to use L'Hopital's rule. So, say we have some function f of x, and it's over g of x. Ooh, that is an awful g. Okay. G of x. And we took the limit as x approached, let's say 0. That's an infinity. Okay, infinity is fine too. Okay, let's say we had the limit as x approaches infinity of f of x over g of x. If we were to just straight up plug in infinity to some random function, and we essentially evaluated the function at infinity rather than approaching infinity, and we got, well, infinity over infinity, this is one indeterminate form. If we had negative infinity over negative infinity, that's just fine. If we had negative infinity over positive infinity, that's fine. Or if we had positive infinity over negative infinity, that is still an indeterminate form. As long as we have some sort of an infinity over another infinity, that's indeterminate form. But if we had the limit as x approached to 0 of f of x over g of x, and we had 0 over 0, that's our other form, or our other indeterminate form. And so what this tells us is, well, it doesn't tell us much. We can't do anything with 0 over 0 or infinity over infinity. So that's why we use L'Hopital's rule, which states that if we have either of these indeterminate forms, then we take the derivative of f of x and g of x. So we would have the limit. Yeah, let's run with the 0 example. So limit as x approaches infinity of f prime of x over g prime of x. That's just representing that it's the derivative of f of x and g of x. And if this gets us some finite number, we're good. If it doesn't, and we still get some sort of an indeterminate form, we differentiate again, and we keep differentiating until we either don't get a finite number and say the limit doesn't exist, or we get a finite number and we say, well, the limit is whatever that finite number is. So now that we have some sort of basic intuition on what L'Hopital's rule does and the cases where you would actually use it, let's go over the example I have. So we have the limit as x approaches 0 of sine of x squared plus 3x over x cubed plus 4x. Now, if we plugged in 0 to this, just evaluating this function at 0, well, sine of 0 is 0. 3 times 0 is 0, so we'd automatically have 0 plus 0 in our numerator. And of course, x cubed, when x is 0, is just 0 plus 0. So of course, we get our indeterminate form 0 over 0, which means we need to use L'Hopital's rule. So first thing I want to do is differentiate the top. So differentiating sine of x squared gets us a, what do you call it? Well, we need chain rule first. So yeah, I'll do it over here. So we would have our limit as x approaches 0, and I'll differentiate both. So sine of x squared is, it's like a function of a function, so we need chain rule. So first is we evaluate the inside function's derivative. X squared's derivative is 2x. So 2x multiplied by the derivative of sine of x, which is just cosine of x. So cosine of x, and let's leave the x squared in. And then, of course, the derivative of 3x is just 3. This is all divided by derivative of x cubed. We use power rule, and we get 3x squared. And, of course, derivative of 4x is just 4. Now that we have it differentiated, we can try plugging in 0 again and evaluating the function at 0. So 2 times, well, 0 is 0. Cosine of 0 is 1, but 1 times 0 is 0. So we would ultimately have, let me write it down here. We would ultimately have 0 plus 3 in our numerator over, and let me write our limit. Okay. I keep writing infinity. Okay. 0, just 0. Okay. And of course, we plug in 0 into 3x squared. That's just 0. Where is my cursor? Here it is. 0, and then 4. Well, 4 is a constant. We don't plug anything into that. And ultimately, we get 3 over 4. So ultimately, our limit evaluates to 3 over 4 for this using L'Hopital's rule. So yeah, this is just a really basic example of L'Hopital's rule. There are harder ones where maybe plugging in 0 doesn't initially get you an indeterminate form. You have to do some algebraic manipulation to get it into an indeterminate form. Or there's ones where differentiating just once is enough. You have to find, second, third derivative of whatever. And there are examples where the limit just straight up doesn't exist. But this is just a really basic example. With the 0 over 0 indeterminate form, of course, we could have infinity over infinity, but this one's just quick and easy, and an easy example to explain. Yeah, thank you for watching.